Alright, hello everybody. Welcome back to Trigonometry. So, yeah, welcome. So, today, we're gonna be talking about some useful trigonometric formulas. Um, you can use these to use what you know and then figure out new things using what you know. So, what you should know is some of the, things like like the Pythagorean theorem for this, like sine squared of theta plus cosine squared of theta equals 1. Um, if you're wondering why that's the case, I'll just draw out the unit circle. Right? Oh, oopsie, that's not a good circle. This topic covers some pre-calc, by the way, so it might get a little harder from now, but I'm here for you. Just know that, and everything's gonna be fine. So, let's say we pick some random point, and this is a unit circle, so when we draw a radius, this length is 1. Here we have the point 1, 0, 1. This is oh yeah, I'm just thinking the complex point. This is 0, 1, or this is 1, 0. Wait, no, sorry. This is 1, 0. This top one is 0, 1. To the left, we have -1, 0, right? And then to the bottom, we have -1 again, but 0, -1. So now we learn from the unit circle that we pick some point and we had some and then it creates some angle theta to the x-axis, and then this length was x and this length was y. Then we learned that the sine of theta equals the opposite, so y over the hypotenuse, which is y over 1, so y. And same for cosine theta. Cosine theta equals x. So now, because this is a right angle and this is cosine of theta, this is sine of theta, then we can use the Pythagorean theorem to say that sine of theta squared, but we write it like this, that way we don't confuse it with sine of theta squared. So we write it like that, and that plus cosine squared of theta, and that's equal to 1. So now we know that. If you divide both sides by cosine squared of theta, or divide both sides by sine squared of theta, if you divide both sides by sine squared of theta, or let's say the cosine first. So we're gonna get 1 plus So if you divide by sine squared or by cosine squared of theta, you're gonna get 1 plus, and then sine because cosine squared of theta over cosine squared of theta is 1, and sine squared of theta over cosine squared of theta is sine of theta over cosine of theta squared, which is tangent squared of theta, and that's equal to 1 over cosine squared of theta, and that is equal to the secant squared of theta. Divide by sine squared, and you get 1 plus cotangent squared of theta equals cosecant squared of theta. Alright, I'm assuming you might only know this in this little review. So now, I want to cover a few things and many formulas, but I'm not going to go over the proofs, I know. But because first of all, it'll take too much time, and second of all, I'm not good at them. And don't worry, because they're all out there, like on Khan Academy and stuff like that, and they're all free to you. And so I recommend you that after you know these proofs, you go to Khan Academy and you look at all the proofs. Okay. So first, we're gonna go over the sum angle formulas. The sum angle formulas are how to find the sine of a plus b and the cosine of a plus b. So this is equal to the sine of a times the cosine of b plus the cosine of A times the sine of B. Right? This is sine A cosine B plus cosine A sine B. Right? You switch. With cosine of A plus B, it's a little different. This is cosine of A times cosine of B minus, notice that this is plus and this is minus, but on the top of the sine you have plus and plus, minus sine of A times sine of B. Okay, so cosine A cosine B minus sine A sine B. Now what we're going to have is we're going to try to do sine of A minus B and cosine of A minus B. Now that you know this addition formulas, the sum angle formulas, how can you do the difference angle formulas? And I want you to try it. Okay, maybe you have an idea in your head, or maybe you wrote it on paper, I don't know. But when you, so this is plus negative B, and this is also plus negative B. So what you can do is you can just plug in negative B for B into the sum angle, and you're going to get sine of A still times the cosine of negative B. But the cosine of negative B, that is, hopefully you know that the cosine of negative B is just negative cosine of B. And that plus this one, we're going to get the cosine of A times the sine of negative B. Wait, what am I doing? Plug in negative B. Oh wait, no, sorry, what am I doing? Sorry. So when you plug in negative B into cosine, it does nothing. Okay? You can just remove the negative. But here, with the sine, you'll have to bring that out. There you go. Same strategy with cosine. So you have cosine of A times the cosine of negative B, but that's just a cosine of B. That minus the sine of A times the sine of negative B. Sine of negative B is negative sine of B, so we can put out the negative, and then negative minus becomes plus. So there you go. These are some of the formulas. Now we're going to go over the double angle formulas. Oh god. So what are the double angle formulas? Well, I'm glad you asked, Billy, or whatever your name is. So the double angle formulas is blah 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 blah. Okay, so double angle formulas is sine of 2a and cosine of 2a. Notice 2a is a plus a, so we can use the formula of addition of the sum angle formulas, and we're gonna get if we plug that in, we're gonna get sine of a times cosine of a plus cosine of a times sine of a. And because of the commutative property of multiplication, that's the sine of a times cosine of a plus sine of a times cosine of a, or 2 sine of a cosine a. Okay, now this now the next one. So so what's the cosine of 2a? Cosine of a plus a. So now we have to, so we plug in that, we get cosine of a times the cosine of a, that's cosine squared of a, minus, then we plug in, so that then we get sine of a times sine of a, but that's sine squared of a. And I'm sure when you first see this, you go, oh, because you see, oh, sine squared plus cosine squared. But then it's a minus, not a plus. So, maybe that's just me. I don't know. I'm just weird like that. So now what you do is so you can use that fact though. You can say that, so cosine, so you have cosine squared of theta equal, plus sine squared of theta equals 1. So we can subtract sine squared of theta on both sides, or cosine squared of theta on both sides, and what do we get? We get another form. So if we subtract sine squared of theta on both sides, we get a form of cosine squared of theta, and we plug that in, and we get 1 minus, so we know that, so if again, like, we subtract sine squared of theta on both sides, and we get cosine squared of theta equals 1 minus sine squared of theta. So we plug that in. We get 1 minus sine squared of theta minus sine squared of theta. So that's 1 minus 2 sine squared of theta. We can also do it a different way. We can find a form of sine squared of theta. And that's equal, and sine squared of theta is equal to 1 minus cosine squared of theta. We plug that in. We get what am I doing? You plug in, yeah. Cosine squared, so sine squared of theta equals 1 minus cosine squared of theta. Plug that in, you get cosine squared of theta minus 1 plus cosine squared of theta. So that's equal to 2 cosine squared of theta minus 1. Okay, cool beans. Cool beans. Now we're gonna go over the half angle formulas. Yay! So the half angle formulas, as you guessed probably, is sine of a over 2 and cosine of b over, or cosine of a over 2. Cosine and sine again. Yay. By the way, I'm not going over tangent, secant, stuff like that because all of them are in the form of either sine or cosine or both. So there's a formula for tangent of a plus b, but you can just plug in sine of a plus b over cosine of a plus b. Maybe you can do some things and get a different formula, but yeah, I don't feel like doing that. So, and they're unnecessary. You just need to know sine and cosine. So here, what's the sine of a over 2? So that's gonna be equal to, what am I doing? Yeah, so the sine of a over 2 is equal to the positive or negative square root of 1 minus cosine of a over 2. And then cosine of a over 2 is equal to plus positive or negative, plus or minus, square root of 1 plus cosine of a over 2. It's pretty nice symmetry, I like that. Almost the same, but different. Nice. Now we're gonna go over some more complicated formulas. If you thought these were complicated, I guess I'm sorry. But I'm not. So anyways, if I was sorry, I'd stop. But I'm not sorry, so I'm not stopping. So let's move on. Now, sum to product formulas and product to sum formulas. I've struggled to memorize them, and I really hate them. But they're so annoying. So basically what it says is that sine of a plus sine of b, and and then we're gonna do cosine of a plus cosine of b. What are they equal to? So sine of a plus sine of b equals 2 times the sine of a plus b over 2, average, right? Nice, times the cosine. And then because cosine is really depressed, they always like to do minus signs. I'm not gonna ask why, because maybe they're too depressed to talk. So now with this, we're gonna have, I'm not making fun of depression. I'm just saying that cosine is depressed. So now cosine of a plus cosine of b, that is 2 times the cosine of a plus b over 2. Hey, now he's happy. But because he's happy, the sine got depressed. The sine was happy when he was depressed. Wait. What am I doing? Oh, oops. Yeah. I was doing this all wrong. So, yeah, sorry, this is sine. Wait, no, I was right the first time. Never mind, guys. It's okay. Cosine. And then, what was I doing? Okay, yeah, now cosine is happy. And sine got so sad that he got blown out of existence. So now we have cosine, but now cosine is sad because he liked it when sine was sad. I don't know what I'm just making this up. Anyways, yeah, I'll use the formulas. So, and cosine is very selfish, so he has 2 cosines, but sine shares. Sharing is caring, guys. So sine and cosine. I'm wasting my time now. And I'm wasting yours. So moving on. As you might have guessed, there's also sine of A minus sine of B. Hey, I love these so much. So many formulas. Imagine just having one general formula for all of them. That'd be great. Like it's be like a general of a general. Remember inequalities? Oh god, back then I used that same thing. So now what's sine of A minus sine of B? That's equal to 2 times the cosine of A plus B over 2 times the sine of A minus B over 2. So now cosine was so sad over here that he called sine back. And now he's happy, but sine is sad. So sine at least he's not blown out of existence. So he's less sad. So now cosine of A minus cosine of B. What's this? That's equal to... No, this is gonna be crazy. So now, because sine is sad, cosine got sad for some reason. Oh yeah, no, because sine was sad, so then the police came, and then cosine was scared, so then cosine got sad. And then everyone was so sad that it became a -2 in front rather than +2. And it broke that barrier that cosine, now cosine's out of existence, and now it's just sines. Times sine of A minus B over 2. Okay, that's how easy this is, okay? Just remember the story, and you're gonna be fine, okay? And why do I have math things here? I'm not even good at math. I mean, I'm really good at math. I'm the best at math. That's why you're watching this video. So, yeah. So, of course, because we talked about product, about sum to product, we need to talk about product to sum. So, now we're going to be doing the sine of A times the sine of B. So the sine of A times the sine of B. Oh my god, I love this so much. So this is gonna be equal to the cosine of A minus B minus the cosine of A plus B over 2. Yay! Now I gotta do the cosine. Cosine of A times cosine of B equals same thing with sine, but different. So sine, but instead of A minus B first, you're gonna have A plus B first. My sloppy handwriting is probably ruining this for you guys, but minus the sine of A minus B. Remember, sine is happier. So sine does happiness first, then sad. So yeah, like in the story, the sine was happy first, then sad, and then in the story, cosine was sad, and then oh yes, sad and then happy. It's beautiful. I love this. Oh yeah, over 2. Wait, what if 2 is the police? Dang, son, that went deep. That's what she said. Okay, anyways, so now here you're gonna do sine of A times the cosine of B. So we're combining them now. We're also gonna do sine of B times cosine of A. Notice these are kind of like, hey, they're kind of like the sine of A plus B formulas. That's pretty cool. So what if we use them to our advantage? Oh, that's such a genius idea. Well, maybe not with sine of A times cosine of B, because... Wait, what am I doing? Actually, you know what? Yeah, we are going to use them. Wait, was I doing this formula wrong? Oh, oopsie daisy. Wait, I'm confused. Let me check. Okay, so sine of A times sine of B. I got that right. Wait, no, I didn't get that right. Did I switch them or something? This, sine of A times sine of B, is going to be equal to the cosine of A minus B minus the cosine of A plus B. Remember, sad then happy. Don't do that. Now, cosine of A times cosine of B That's equal to the cosine. Wait, what? Did I do this again? No, okay, I'm doing this right. Wait, what? Oh, I only did the second one wrong, maybe? Yeah, okay, yeah. Happiness, then sad. No. Okay, cosine of A times cosine of B. What's that equal to? Please. Oh, yeah, sadness first, right? But then that's the same formula. Cosine of plus the cosine of A plus B. Did I get this one right now? Oh, the only difference is the minus and the plus. Okay, cool. Sounds great. Now sine of A times cosine of B. That's equal to the sine of A plus B plus the sine of A minus B. Sine of A times cosine of B. Okay. Okay, good. Over 2. Here we're going to have the sine of A plus B minus the sine of A minus B over 2. And we're done. JK lol. That's all of those. But, memorize these. I've gone a long way without memorizing these, but I can't really say that. So, memorize all of them. Yeah, do that. Now what? Now we're gonna be talking about, I guess, solving triangles. So, you might know how to solve right triangles, but what if you had some random triangle? Some oblique triangle. And you only know some sides, some angles. How to solve the rest without using some similarity and congruence. You can't, there's some problems that you just need trick for. So, we're going to be learning about the law of sines and the law of cosines and the law of tangents. JK lol, we're not going to do that because that's too useless. Get roasted. Now, law of sines says that the sine, oh, by the way, let's say it's a random triangle, right, where its points are A, so this is angle A, this is angle B, this is angle C. And then we had side lengths of A, B, and C. Notice that angle A and side length A are opposites of each other. So the law of sine says that the sine of A over A equals the sine of B over B, which equals the sine of C over C. I don't know if we've talked about this before, but yeah. You can also flip them all, so you can have A over sine of A equals B over sine of B equals C over sine of C. Law of cosines states something even a little harder, and there are two forms of the law of cosines. The first form is that the cosine, oopsie daisies. Sorry, the first form is that A, or I'm going to do C. So if we want to solve for C, and we only knew the angle C and the side lengths A and B, so we know everything. So we know everything except for these two or these three. How can we solve for this? I know, it's really, really hard, and I know you want to cry. So first step, cry, right? That's what my teacher taught me. Literally, that's what my teacher taught me. First step in a math problem is to cry. Now, how do we solve for C? So, by the way, we're solving for the side length C. So, little c. So that squared is equal to a squared plus b squared. Yay, that's a right triangle. But that's not always the case. So when we have any triangle, we subtract 2 times a plus b, or 2 times ab times the cosine of c. Notice in a right triangle, when we have that, if we're solving for the hypotenuse, its opposite angle is going to be 90. So the cosine of 90 is 0, so this will cancel, and we just get the Pythagorean theorem. Now, we can also do it for the rest of the angles. So we'd get a squared equals b squared plus c squared minus 2bc cosine of a. You can see the pattern. It's like the sum of the squares of the other sides minus 2 times those sides multiplied times the cosine of the angle opposite of the side you're trying to solve. That was really confusing. So now b squared equals a squared plus c squared minus 2ac times the cosine of b. Yay. Now there's another form, this is one form, and there's one more form for law of cosines. This one, it depends on which type of problem you have. This one is for solving these top three were for solving side lengths. What if you wanted to solve for an angle? So to solve for an angle, you can solve for any angle by knowing all the sides. Wait, what am I thinking? Yeah, you can solve for the cosine of an angle if you just knew all the sides. I think, right? So you have cosine, of course, because law of cosines. Duh, bruh. So cosine. Oh my god. So duh, bruh. So you're gonna have cosine of c is equal to. You can actually solve them out algebraically, but I don't feel like. So that's equal to a squared plus b squared minus c squared, or over 2ab, I think. Multiply by 2ab. Subtract. Yeah, okay. Now you can get from here to here a lot easier. Oh, I just did it in my head, so that's nice. Not to brag, but yeah, I did it in my head on my own. So now cosine of a is equal to, by symmetry, we have the same thing but different. So b squared plus c squared minus a squared over 2bc, and then cosine of b is obviously equal to a squared plus c squared minus b squared over 2ac. Alrighty, so this is all of the things you need to know. I know I'm a bad teacher saying to memorize all this, but please look at the proofs on Khan Academy. They're really good. I don't know why I'm promoting Khan Academy, but I am. So yeah, go. So I know you guys know Khan Academy, so just go there, and yeah, you'll see all these formulas and remember them. So, yeah. You never know when you're gonna need them. They're useful. So yeah, see you guys next time. Goodbye.